Okay, welcome back. So in this video, we're going to see how we calculated our wall loads using the dimensions given to us. So these were the dimensions given to us. And then using the formulas given in the codes, we're going to see how we're going to calculate the wall load. So here, when we look at this, we have got the main wall load is calculated as follows: wall thickness times wall height times unit weight of brick. So all these are millimeters and newtons. So when you calculate the wall thickness was 230 and the wall height was this much, and unit weight of brick is in the code is 19 kilonewtons per meter cubed, which is 1.9 times 10 to the power minus 5 newtons per millimeter cubed. When you calculate, we're going to find our wall load to be this much. Our internal wall load, using the same equation, we're going to find it to be this much. And our floor load is going to be designed as follows: slab thickness times density of concrete. And then we're going to add floor finish. We're going to get floor finish of 1 kilonewton per meter cubed, which is 0.01 newton per meter squared. And the density of concrete we all know is 25 kilonewtons per meter cubed, which is around 0.025 newtons per millimeter cubed. So after we do this, we're going to calculate our floor load as this. So we're going to assign all these floor loads into our design. So the first thing that we need to do now, let's save this. We're going to get load. We're going to add. The first things first, add self weight minus 1. When we add, it's close. It has assigned its self weight to the whole structure. So we're going to select this option, assign to view. And we're going to assign. Let us now add those dead loads. We're going to go to the member loads because beams and columns are members. We're going to go to the member loads and unit force. So the first load, the first main wall load that we have is this one, 10.7065 newton per millimeter squared. So what we're going to do is that, since this load will be acting downwards, so we're going to add a negative here, negative 10 point. It's negative 10 point, negative 10.7065, 10.7065 newtons per millimeter. These dimensions D1, D2, D3, we need to make them 0 because the load will act at the center of the beam here. And then we're going to, the direction is global y-axis. We're going to add, and then we're going to add the internal wall load as, minus, so we're going to add the internal wall load as minus 5.5865. So minus 5.5865 newtons per millimeter. Global y-axis we're going to add. After we've done that, we are going to, and then for this type, let's just close this. When we do this, we are going to assign this. This is the main wall load. So let's how we're going to assign it. Go to the plan view. Let's do this. Let us select all these beams. So we select this. So these are outer walls. So these are outer beams. We're going to assign this wall load to the outer beam. Let's see how we are going. Okay, so as you can see, we've selected only the outer beams. We're going to assign to selected beams. Assign. Yes. So as you can see, the load is applied. As you can see, these are arrows for the wall load. And now we're going to select the internal walls. So internal wall load, we're going to select it be like this. So we select this one. Let us select the same beams, the outer walls. We'll see how we're going to assign it. Now, let's select this one. Select this one. Select this. Select this. So as you can see, the outer walls have been selected. Let us now use a trick that we use to select the inverse properties or the inverse beams. So we're going to go to select, and we're going to go to an option called by inverse. So when you use inverse, we're going to select the beams that haven't been selected here. So inverse beam selection. As you can see, only the beams inside now have been selected. The internal beams and columns have been selected. Then we're going to assign to selected beams and then assign. Yes. So as you can see, only the beams inside have been associated with this load. So self-weight already done. As you can see, the outer wall. When you select a load formation here, the load that is associated with this formation appears as blue. So, and then the one which is not selected is green. You can see blue, the outer wall, green, the inner wall, blue. Now let us select another dead load called slab load or floor load. So we're going to add. When we add, let's first see our slab load is this 0.001025 newtons per millimeter squared. So we're going to do. So dead load, add. So we're going to assign it. There are two ways. You can use it as a plate load, like slabs, but we want it will take a lot of time to analyze. So we use this as floor load. When you do this, minus 0.001025 newtons per millimeter squared. Let us confirm. 0.001025. Okay, confirmed. Global Y direction. This option is when you are designing a one-way slab or two-way slab. But in this case, all our slabs are two-way slabs. So we're going to design this as two-way. And then we are going to select the range. So the range in the Y direction comes from 0 to the addition of 5,500 millimeters. Since, if we check our section, if we add these two, it's 5,500 millimeters squared. So we're going to select this and we're going to add, then close. So when we select, have you seen? Our slab would have been added, and then we can see the partition of this load per beam. Now, our live load in residential areas is mostly taken as 2 kilonewtons per meter squared. So we are going to add live loads. In Staad Pro, live loads are added as flow loads. So we're going to add flow loads. It will be minus 0.002 newtons per millimeter squared. So then we're going to add, and then this will be up to, the range will be to 5,500. This range means that the starting point is 0 millimeters in the Y direction. Then we'll end at 5,500 millimeters. So in this range, our load will apply. Our load will apply between this type of minimum maximum. So we're going to add and close. So when you press here, as you can see, our loads have been added, our live load, and then our loads here have been added. So every load has been added, from dead load, the self-weight added, internal wall, the beam, internal walls have been added. When I select a load combination here, we're going to see that this load is associated with a color blue. So when I press here, the internal wall load has been selected, so it's blue. The flow load, dead flow load, it's blue. Live flow load is blue too. After we've done this, and then there are two ways we can do the next step. We're going to add load combinations. So if we study IS 456, we're going to find that these loads have to be combined in such a way that there are partial safety factors combined within. So we are going to add them. We can add them manually, or we can just generate them. So the most simple way for a simple building such as this is that we are going to use load combination. So how we're going to do this? We're going to go to commands, we're going to go to loading, then we're going to go to automatic load combination. When we do this, we're going to select the code. It's the Indian code, and then we're going to generate loads. Structure is a general type of structure. It's not steel, it's a general, RCC. So we're going to generate the load. And these are the load combinations that we have. So we're going to add and close. So we've seen, instead of us putting in manually the partial safety factors of 1.5 with each load case, we'll just generate them. So as you can see, when you press here, load combination has been done. Here, same, here, same, here, same, here, same. So this is how loads are added, this is how loads are applied to the structure. The next video, we are going to see how we're going to analyze this building and design it. Thank you.